this section we're talking about the domain of functions, and then we're going to combine functions as well. So you have your rules for domain here. You can also, of course, print them out from our Canvas course. You have three cases. You either have a denominator, you have an even radical, which means it's the square root pretty much. An even radical would look like this or this. That index is an even number, or we'll have all other cases. So that's what we have. Okay, so in this first one, I ask you to find the domain and write your answers in interval notation. So you have a polynomial. So I'll ask you the questions. Number 1, does this have a denominator? It does not. Number 2, does this have an even radical? It does not. So that means that your domain for this one is all real numbers, negative infinity to infinity. What domain actually means is that you can plug a number in and get a real number back. So it doesn't matter what number you plug into this function, you'd always get a number back. And so that means every number is allowed. And so the way that we write every number is allowed is negative infinity to infinity. Okay, let's move to our second one. For our second one, I'll see that we do have a denominator. So since we have a denominator, that's case 1, and case 1 says set denominator equal to 0 and exclude. So my denominator is x minus 3. I'm going to set that equal to 0. And x equals 3 is what I get. Now that's bad. That means if I plug 3 into this function, I get an error message. It doesn't work. So 3 is bad. Okay? So it says you have to exclude 3. Well, this time when we exclude 3, we have to write it in interval notation. So here's our number line. And here's the number 3. Now 3's bad. So what that means is that all of these numbers work, and all of these numbers work, but 3 does not. So we'll get as close as we can to 3, but not include it, and we'll start back at this side and work from there. So this answer would be from negative infinity to 3 with parentheses, and then we would pick back up on this side and go from 3 to infinity. Now most of my traditional in-class students say, you said that we had to exclude 3, why is 3 in the answer? And so my explanation for that looks like this. This symbol in math means get as close as you can to 3 and include 3. So if I had given you this symbol right here, that means negative infinity to 2.9999999 and include 3. But this parenthesis symbol right here means get as close as you can to that number and not include it. So this bottom interval here would be negative infinity to 2.9999999 but not include 3. And so anytime you have something that comes from the denominator, it should use parentheses. Okay, let's try one more of these. So for this function k, I see that it has a denominator. So since it has a denominator, I'm going to set the denominator equal to 0. Do not touch the numerator. Now technically it says set the denominator equal to 0 and exclude. I kind of left that part out, sorry. To solve an x squared equation, we solve it by factoring. The factors of 21 that subtract to give me 4 are 7 and 3. Solve this one, so I would get x equals 7. Solve this one, I would get x equals negative 3. Now those are bad. Remember, those make the denominator 0. Those are the bad guys. So we can't use those. We're going to use all numbers except for those. So on my number line, make sure you put them in order. Here's the negative 3, and here's the 7. And remember, these are bad. So you'll say, well, what's good? Well, all of these numbers are good, all of these numbers are good, and all of these numbers are good. So writing it in interval notation, it would go from negative infinity to negative 3, negative 3 to 7, and 7 to infinity. That's your answer. Now the multiple choice on this for my online classes, the multiple choice is very tricky. This particular one, let me write it down here at the bottom. This gray choice here, that would have been one of your answer choices. Do not fall for this. This is a trick. This is tricking you to see if you understand interval notation or not. That leaves out every number that's in the middle. That leaves out 0, and it leaves out 6. It leaves out any number that lies right here. And so that's why we don't want to write, we want to make sure we get all 3 intervals in our answer. Okay, so let's grab the last 2 of these. Okay, so you see H and M, and at first glance you think that they're the same. But remember, H is a square root, which means there's understood to be a little 2 right there. Now, a 2 right there is very important because that means it's an even radical. If I look at my second example, I see a 3. Well, a 3 right here means that this one's going to be an odd radical. Okay, so let's get started with these. Question number 1, or case number 1, says, does this have a denominator? Okay, I'm on the H problem. This does not have a denominator. So question number 2 says, does this have an even radical? Yes, this top one does have an even radical. So the procedure says, take your radicand and set it greater than or equal to 0. So I'm going to take x plus 5 and set it greater than or equal to 0. So solving that out, I'll move the 5 over, and x would be greater than or equal to a negative 5. So writing that in interval notation, it would be from negative 5 to infinity. Now, one of the things I want to really stress, especially in a multiple choice format for my online classes, is this symbol right here means bracket. So make sure that you put a bracket on this part. It means bracket. Let me write the answer one more time. So when we get ready to write this one in interval notation, it would be a bracket, negative 5 to infinity. Okay, let's look at the last one of these. So what I notice about this one is it's an odd radical. It does not have a denominator. Okay? It does not have a denominator, so it's not case 1. It's not an even radical, so it's not case 2. So that puts it at case 3, and your answer for anything in case 3 is negative infinity to infinity, and that's how you would do that one.